In this video, I will be doing a number theory problem. The sum of 4 distinct natural numbers is 2025. Then the maximum GCD of these 4 numbers is. The minimum LCM of these 4 numbers is what? So we have 4 distinct natural numbers. We can mark these. Let 4 distinct natural numbers be P, Q, R, S. So their sum will be 2025. So P plus Q plus R plus S equal to 2025. We want to find out the maximum GCD of these 4 numbers and the minimum LCM of these 4 numbers. Well, for this question, we will need to use something called the short division model. It's a very common use model when solving the GCD and LCM of numbers. It can be represented like this. So this is a short division sign. A, B. So like let there be 2 natural numbers, A, B. And then their GCF will be D. And then A equals to dx, B equals to dy. So from this, like if GCD AB equals to D, then this happens. Then you can get 3 a very useful fact from this. And it can be easily proven. Well, A equals to dx and B equals to dy. This is the most obvious one. Then x and y are co-prime because since D is already the greatest common factor, x and y have to be co-prime because dx equals to A, dy equals to B. And then you'll get that LCM AB will equal to dxy. So for the last one, well, the only difference between A and B are x and y. So the LCM will just be x times y times d. For example, we can apply this short division model on like 2 numbers. Let's have them be 10 and 15. Then d will equal to 5. 10 equals to 5 times 2. 15 equals to 5 times 3. LCM 10, 15 equals to 5 times 2 times 3 equals to 30. And this is true. So using this, we can solve this problem. So let P equal to, let GCF PQRS equal to D. P equals to DA, Q equals to DB, R equals to DC, and S equals to we can let this one be D times E, DE. Okay, so DA plus DB plus DC plus DE, because the sum of them is going to be 2025. So these will have a sum of 2025. Or you can simplify, factor out D. A plus B plus C plus D plus E equals to 2025. And then, now, let's prime factorize 2025 because we know that D has to be a factor of 2025. So 2025 will equal to 5 squared times 3 to the power of 4. Now you might be wondering, so can D just be 2025 corresponding maximum? Well, no. This is because these are distinct natural numbers. And distinct means that they have to be different. So minimum is going to be 1, 2, 3, and 4. That's the minimum. We can't have them all be like 1, 1, 1, 1. So now, these add up to 10. But then 2025 doesn't have a factor of 2. We have to go to the next biggest one. Next smallest one, which will be 15. So D max will equal to 5 squared times 3 over 4 divided by 15. Like 5 times 3. This will equal to 5 times 3 cubed. Which will equal to 27 times 5, 135. So now we have the first one done. Now, let's, not 2225, 135. Okay, now, for LCM, from the short division model, this will equal to DABCE. So, let LCM PQRS, well, we can let this equal to M, and M will equal to DABCE. Okay. Then let's reuse the fact that the sum of the 4 natural numbers is 2025. This is the only thing that we need to solve for the LCM actually though. Because you see, the M over alpha 1. Let alpha 1 be like, M over alpha 1 will be equal to P. So, and then plus M over alpha 2 plus M over alpha 3 plus M over alpha 4. We can do this because we are sure that P equals to dA, and since M equals to DABCE, so we know that P is a factor of M, obviously because M is the LCM. So let A1, A2, A3, alpha 4 be the P times A alpha 1 equals to M, and then Q times alpha 2 equals to M, Q times alpha 3 equals to M, and then S times alpha 4 equals to M. And then the sum of these will just be P plus Q plus R plus S equal to 2025. And then you can factor out M now. 1 over alpha 1 plus 1 over alpha 2 plus 1 over alpha 3 plus 1 over alpha 4 equal to 2025. And now, to minimize M, we have to maximize this alpha 1, 1 over alpha 1 plus 1 over alpha 2 plus 1 over alpha 3 plus 1 over alpha 4. And how do we do that? Well, remember that in fractions, the smaller the denominator, the larger the fraction. So, like, if you have alpha 1 equals to 1, that's the largest the fraction can get. And so let's try that. Let alpha 1, alpha 2, alpha 3, alpha 4 be 1, 2, 3, 4 respectively. Because once again, they're different numbers. So M times 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. Know that these are the largest possible fractions for this problem for the 2025. And the sum of these will be, well, to add fractions, you have to find the least common denominator, which will be 12. So 12 plus 6 plus 4 plus 3 will equal to M times 18 plus 7, that'll be 25. 25 over 12. In 2025. And luckily for us, this one will work. You know, sometimes if this doesn't work, you have to go to the next biggest one. But this problem, luckily, this one works. So M equals to 2025 times 12 over 25. And this will be 81 So 81 times 12 will be 810 plus 162. It will be 972. So that is how you solve this problem. The key point of this problem is only the short division model. This is a very useful model to solve GCD and LCM. Using this, you can replace PQRS, and then to find a maximum, you have to find a minimum of A plus B plus C plus E. To find a minimum of LCM, you have to maximize 1 over alpha 1 plus 1 over alpha 2 plus 1 over alpha 3 plus 1 over alpha 4. So that's how you solve the problem. Thank you for watching.